Okay, so this video is going to be all about linear functions and the next videos to come. So this video is just going to provide you with the very basics, and one of the key parts of a linear function y equals mx plus b is its standard form, and m is the slope. And that's what we're going to look into in this video. So slope is rise over run. And what that means is if your slope, let's say your slope is 1/2, okay? And let's say the graph starts at the origin. So if your slope is 1/2, y equals 1/2. Anyways, if your slope is 1/2, rise over run. The 1 is rise, go up 1, over run. The 2 is considered run. So 1, 2, rise over run. And the same can be said for the other way around. Rise, or going down, 1, and going over to the left, 2. 1, 2. So that's just an example of how slope works. Now that's if you have slope. If you want to find slope, actually, if you want to find slope, you use this. Slope, again, slope is represented as m. Slope is y2 minus y1 over x2 minus x1. Now what this means is if you have to have 2 points, 2 coordinate points to be able to use this. So if you have 2 coordinate points, let's say 1, 1, and 3, 4. Okay? If you're given 2 points, you can use this to find slope. So, and the 2 points, 1, 1, and 3, 4, it doesn't matter which ones you count as x2 and y2 or x1 and y1. It doesn't matter, but you can't mix them. You can't say that this is x2 and this is y1. They both have to have the same 2 subscript. So, as always with all coordinate points, this is considered the x value, and this is considered the y value. So, let's say this is x1, and this is y1. And this is x2, and this is y2. Again, I could say this is y2 and x2, but I can't mix them. So let's go ahead and use that formula. So y2, 4, minus y1, which is just 1, over 3, which is, x2, which is 3, minus x1, which is 1. 4 minus 1 is 3, and 3 minus 2 is 2. 3 minus 1 is 2. So this, right here, is your slope. So this is how you find slope, given 2 points. Now, slope can also represent a rate of change. So, meters per second, kilometers per hour, miles per hour, all of that is slope. So if they say, and it doesn't only apply to linear functions. The slope of a quadratic function, which I mean that's like derivative and stuff, you may not get to that yet. It's not in the SAT. But the slope of any graph is the rate of change. Now, depending on the axis of the graph, let's crooked, but it's okay. So if the x-axis is hours, and the y-axis is miles, then the slope is going to be miles per hour. It's the rate of change. So when they say find the rate of change, you just find the slope. So let's try an example. Yeah, I can write that here. Alright. So, if you need to pause it and make sure you have this down, this is basically the beef of what's in this video. Alright, as always, feel free to pause the video and try this on your own. And if you're stuck, just resume. So, just like we said right before this, it's asking for a rate of change. It's asking for a speed. Rate of change is speed, velocity, all that stuff. Miles per hour. And what it says here, maintains a constant speed, that's just saying it's linear. It's not a quadratic equation, it's not something else. So we can use m equals, slope equals y2 minus y1 over x2 minus x1. So this first sentence here is just telling us that we can use this, because this is finding slope of only linear equations, which is all you need to know. You don't need to know about quadratics yet. So yeah, this will get you the slope, and slope is the rate of change, so that's what you're looking for. So just go ahead, plug these in. y2, let's say this is y2, and this is x2. So y2 is 8 minus 5, this is y1, minus 2, and x2, which is this, 5, and x1 is 1, so 5 minus 1. 8 minus 2 is 6, and 5 minus 1 is 4. And that can simplify to 3 over 2. So yeah, that would be your answer choices. Your answer choice. In miles per hour, yeah. And if the answer is in a decimal, just do 3 divided by 2 in your calculator and you get something. So yeah, that should be it for this video. And next video, we're just going to keep going more into linear functions.